Hi. I've been away for a couple of months because I had some issues in the refinery software, and actually I've been busy with other stuff, so I want to redo this one. I want to make it in another way. So let's assume everything we did earlier will be just learning the stuff. We'll redo it again. So I already pre-assembled a part of this video so we can understand it better and quickly. So we'll start by creating a base. So we have a circle by center point and radius. Radius is 20. And here we have a polygon with 3 sides. It's a triangle. Afterwards we want to create surface by batch, this one, and also we want to explode the polygon, take the endpoints, and afterwards get the items. So here's the endpoint. We have 0, 1 and 2 items. You can see it in the background. Now on the other hand, we have this top point. We have circle by center point and radius, also another polygon, and a geometry rotate workflow. The rotation right now is 60 degrees, and the vector is z-axis we are rotating about. The origin is the same point, and the height of the point is connected with this parameter. This is the size of the tower. The radius, it can be found right here. So the bottom radius right now, you can see it's smaller than the top radius, so we can change it. Let's try to make this 30, this one 25, and run. Let's put this to automatic. Now we did the same thing right here for the polygon that's up there. We exploded, took the endpoints, and here you can see we have the 6 points that will do the tower. So here we can have this group. It's called point 1 deform, point 2 deform, and point 3 deform. If we select it, you can see that we have this transformation node. If we just showed it, you can see that it's right here. It's changed the position, and we're doing the same for all of the 3 points. Now this is for the shape optimization. So right here you can see that we have an integer slider, which is an input. All of these are integer sliders. The A is connected to the size, and this is for the top point. The bottom point does not have a deformation. So right here you can see that this is a multiplication of the numbers and also a division. And here you can see the coordinate system, and the values taking the x from here, the y is from another value. It's -5, -10. We can change it as we wish. And here we have the top, which is the z. It's also have another formula. It's basically the same thing, and this is repeated for all the 3 points, 3 top points. The bottom points can be found right here, and here you can see the roof. If we join this and create show, this is the deformed roof, and it consists of all the 3 points, and they're creating a polygon again and surface by patch. Now related to the sides, we're just taking the points and connecting. So let's hide those and show all of those. So here's our tower. Now again, all of those are connected right here. Here are all the surfaces. From these surfaces we created a polysurface by joint surface, and then we are intersecting them with planes. Now we took a bounding box by geometry. So this bounding box is around the roof, and afterwards we have the minimum point of the bounding box, and we took the Z value, and this is the numbers. So the lowest point of this inclined roof, it will be the highest floor we will have. So these are this is a series of numbers that's starting from 0 and reaches to this number, which is now 126. And this is the floor height. Now this is also an input, and it can be variable between 350 and 500. Actually, for now I want to make the values a little bit different. I want to make this 400 and the maximum 500. And now it's in meters. Now I'm using this one because I'm using integer sliders, and this is just to convert the units to meters. Right now here we have the point by coordinates, and we're creating the planes out of all these points. So if we hide those, you can see that we have many planes, and the plane's intersection with the polysurface is right here. We want to skip the first list since it's a surface. So here's the rest of items, and afterwards we have the polycurve by joint curves. So you can see that each floor have multiple lines. This node will ensure that every floor will have just one polyline. We create a surface by batch, and afterwards we can join the list. Since here we had this surface, the first floor, we can join the list, and afterwards we took the total area, or we took all the areas of the floors and summed them right here, and this is a rounding node. So this is the built up area. It's around 34,000. The cladding area, it took the surfaces of the whole surfaces of the building, and took the area, and also took the sum and rounded right here. So let's continue our workflow. We want to optimize the shape a little bit more, so we can go again right here, and let's try to run refinery again. And before I do the study, I want to zoom out and hide the stuff that I don't want to show. Maybe remove this one, hide it, and show the surfaces. So let's save, go to Refinery and create a new study. Now we want to optimize. The inputs will be the points and the coordinates of the points and also the floor height. The output will be the built-up area and cladding area. We want to maximize the built-up area. Cladding area should be minimized. The setting, let me have 20 generations and generate. I'll speed this up. Now here's the options we have. I want to show the coordinates, parallel coordinates, and I want to use some filters. I want the maximum built-up area. Let's see the options we have available, and here you can see that these two options seems the best. I think I'm preferring this one. We can also go to other options. We can see it right here. We can see that most of the options have the minimum inclination in the roof, so it's fine. So let's settle maybe on this one. It have a better inclination, and let's wait until it recalculates. Here it is. So now we want to continue with the design. We'll explore other options later, but we want to continue with the inclination. We want to study the inclination we have on these sides and see what's the angle right here. So we'll start by going to the polygons. We want to see the sides, and I want to create a list, join component, and we'll connect these polygons. Now I want to explode the geometry, and I have these 9 curves. I want to, let's try list remove item at index. Then we want to make the lacing to longest. Let's click 0 and hide all of those. You can see that we have only the diagonal lines, which is great. Now I want to flatten this. And take the start point, end point, create a vector by 2 points, now I have these 6 vectors. I want to calculate the angle. Angle with other vector, which will be the z-axis. Here you can see that these are the angles. So I want to check if we have the values that equals 90. I want to separate them and then remove some items. So right now there's nothing. This is an empty list. I'll take the out list. So I want to remove the items that's more than 90 degrees. Here it's 170, 170 and 170. The index are 1, 3 and 5. So I'll create a get item at index and remove item at index. Here are the indices. So here we have the list separated. I want to create this code block 180 minus A. I'm sorry, I want to make it right here. So it gives us the inclination in degrees. It's all around 9 degrees. And this will be the same value. So I want to join the lists and find the sum. Now, I want to make the sum less than a certain number. So I want to create an integer slider. For example, and make the values between 5 and 50. So this is a slider that is the allowable inclination. And I want to subtract these numbers from each other. Now I want to make the allowable inclination 40. And I want to optimize the shape for this value. Or we can do another thing, that is just make this an output and name it. So let's save, go again to refinery, launch refinery, and create a new study. This time we want to just ignore the cladding area and minimize the inclination. So let's compare the results. Here you can see the minimum inclination is right here. Now here we have the built-up area. This is maybe the best option for the built-up area and inclination. These are the two options. Let's choose this one. You can see that the inclination is still high, but we want to cope with this one. So let's change to another item now. So let's calculate another thing, which is the main beam's length. So the main beams or the main members, these will be the supporting elements for this structure. We want to calculate the length. we can also optimize this one. This will be the amount of the curves, so the total number of the curves. This will be the total length of the curves of the shape. So we can go to the same members right here. After removing the zero index and flattening the list, here they are. And we want also to calculate the members of the roof. So we want to create a list join node. And this will take the roof. But we want to explode the polygon first. Here are the curves. Afterwards, we want to take the curve length and also calculate the total. And round. Maybe you can just take the ceiling of this number. So here it is, 1140. This will be an output, and we can also optimize to this one. Now I want to skip to another thing, which is the estimated cost. So I want the cost to be calculated by different items. One of them will be the inclination, the other will be the cladding area, and the beam's total length, we can just skip it. Maybe we can use the built-up area for this. It will be a great thing. So the built-up area will just calculate the finishes, and the structure will be calculated by the inclination mostly, and by the membranes if we want to add them. And the skin cost is by the facade area. So this will be a very rough estimate, but it can be relatively good for each of the options. So we'll start by getting the three values we want: the area, the built-up area, the surface, and the inclination. And we want to create some formulas for them. So for example, if I took the cladding area and let's say A times B, so the A will be the cladding area, here's the number, and B will be the price. So I'll create an integer. Let's make our number slider, does not matter. Let's create this one and make the minimum 100 and the maximum 1000. And this is, let's say, for dollar, and I'll call it cladding price per meter squared. So this is the price, for example, and if we just multiply this, we can have the value. So this is for the skin. The interior finishes will have something similar. I'll just copy this and I'll name it finish price per meter squared, and I think this will be smaller than this one, and the value will be calculated from the built-up area. If I go to the built-up area right here and connect it, let's name this skin cost, and this interior finishes cost, and for the structure I want to create something simply A multiplied by A multiplied by B. So B will be the price unit. I'll call it just structure price, and A will be the structure itself. Now I multiplied this 2 times because we have something that's really crucial in the structures. It's the inclination. The inclination should logically affect the price in a great manner. So here you can see the number, which is around 15 millions, and for now I want to do another calculation. This will be for the members, so I'll call it members price per meter. I think it should be something a little bit small. This should be increased. So the member price will be linked to the total length. So here it is. Now also I want to add something. I think this will be more than this number. So I want to add another pricing factor, which will be the structure area. I'll call this structural members price per meter squared, and I want to add the other factor, which will be the built up area, and this time for the structure. So it will calculate the cost of the slabs and the other structural element. Here you can see that this is 35 million. I think this is too much. It's maybe something around 10 millions. Actually, I'm not an estimator, so I just calculate things roughly. But we're just discussing the methods. So let's calculate those. I'll call it A plus B plus C. And here's the number. Now this method will be not good to optimize the price because we do not have its output right here. But I'm already going to also add these factors, so I'll just create list join. We can just plug those right here. I'll put this aside. Let's delete this one, and this is the building cost. This is the structure cost, and I'll call this architecture cost. So these will be the outputs. I'll just save, and now go again to refinery, launch refinery, and this time I want to create a new study. The inputs will be the same. The outputs, we want to maximize the built up area and minimize the inclination. Cladding area, we'll ignore it, and we want to make, oh, it says that this is the output type is unknown. We want to change it. Oh, we just did something. We forgot to add the math sum. Just do some renaming. Just remove the is output from here and make sure that these are outputs. Let's save again and go to Refinery and create a new study. So now we want to make the built-up area maximized, ignore the cladding, the inclination we wanted to be minimized, and the math ceiling is the members, we forgot to name it. The structure should be minimized. The building cost or architecture, let's ignore it. And the building cost should be minimized. Let's put 100 generation for this and a seed of 45 and generate. I'll speed this up. So now let's go to the parallel coordinates, and here you can see there's a lot of numbers. I want to take the minimum amount. This is for the architecture, this is for the building. Let's go to filter and start by anything less than 35 millions. I think less than 35. This one we do not need it a lot. Let's check these values. Let's find the maximum built up area. Maybe just remove this. And this is what matters for us. So from these options you can see that these are the best we can acquire, and the rest is for our preference. Proportion wise we can choose whatever we want, but unfortunately you can see that the built up area is not that much because we set a low budget. Let's increase it with 5 millions. You can see that we have almost you can always see that whatever we increase the cost, almost the building, the built up area is something relative to it. We can choose this one, it looks nice, and let's click on the X button. So here's our building optimized. Now in the next video we are going to create some geometry inside Revit based on this building. So thanks for watching.